Open your book to page 25. We are starting in lesson 2 for today. It's called Equations with No Solution or Infinitely Many Solutions. So we have two learning targets. The first one is to identify equations that have no solution. What that means is every time we plug in a number or substitute a number in for the variable, we are going to get a false statement. The second learning target is identify equations that have infinitely many solutions, or sometimes I write IMS to abbreviate. This means that every single time we plug in a number, we are going to get a true statement. Every single number works as a solution. So just a reminder of a vocab term, a solution of an equation with one variable is a number for that variable that makes the equation true. So we're going to take a look at questions A, B, and C, and we're going to move away from the directions in this question a little bit just to make it somewhat easier or simpler for us. So if I'm looking at question A, on the left-hand side, I have 9x plus 5. I can't simplify anything on the left, so let's take a look at the right-hand side. I have 4 in front of parentheses, which means we need to distribute. So let's do 4 times x, which is 4x. 4 times 2, which is 8. And then we have plus 5x. On the right-hand side, I notice that I have like terms. I have a 4x and a 5x. They're both on the same side of your equal sign or your line. So because they're on the same side, we want to keep the sign here. So positive 4 plus 5 is 9x. Now, I could stop right here and notice that I have a 9x on both sides. But on the left, we have a plus 5, and on the right, we have a plus 8. So let's say I take a number, let's say x equals 1, and I plug it in right here for x and right here for x. 9 times 1 on the left and 9 times 1 on the right is going to give us 9. But then on the left, I'm adding 5, and on the right, I'm adding 8. 9 times 1 plus 5, 9 times 1 plus 8. Those are never going to be equal. Or if I take this a step further and get my x terms together on one side, so subtract 9x, those cancel. Subtract 9x, those cancel. I'm left with 5 equals 8. Is 5 ever going to equal 8? No, $5 does not equal $8. 5 cookies does not equal 8 cookies. So this is a false statement. 5 is never going to equal 8. So no matter what number we plug in, we will never get a true statement. So therefore, this problem has no solution. Question B. My x terms are different, my constants are different. This looks like what we've been doing in lesson 2.1, 2.2, and 2.3 that you've already taken a quiz on. So let's just solve this equation for x. So I'm going to subtract 3x because that's the opposite operation. Whatever we do to one side, we must do to the other. So 7 minus 3 is 4x minus 10 equals 14. Now I have a constant term and a constant term. I want to move those together on the same side of the equal sign, away from my 4x because we're trying to isolate it. So the opposite of subtract 10 is to add 10. Four and x are being multiplied here. So the opposite of multiply is to divide. Divide. We get x equals 6. X equals one number, one solution, which this is what we've covered previously in our lessons. So the book decided to throw it in here. Question C. I can't combine like terms or distribute on the left, so I'm just going to leave it alone to start with. On the right, we need to distribute, which is multiplying. So multiply 3 times x, multiply 3 times 1, bring down your minus 15. I have like terms on the same side of your equal sign. So we're going to combine those like terms. Three minus 15 is negative 12. What do you notice? What do we notice right here? Everything is the same. My variable terms are the same. I have a 3x and a 3x. My constant terms are the same. I have a negative 12 and a negative 12. So any number that we plug in or substitute in right there for x is going to give us a true statement. 3 times 2 minus 12 equals 3 times 2 minus 12. Or we could take this a step further and subtract 3x from both sides. Negative 12 equals negative 12. That is always going to be a true statement. Therefore, our answer here is infinitely many solutions. IMS. Question 2. Just a reminder, an equation has no solution if there is no value of the variable that will create a true mathematical statement. An equation has infinitely many solutions if there are an unlimited number of values of the variable that will create a true mathematical statement. So no solution is where there are no numbers that work. Infinitely many solutions is where every single number works. It gives us a true statement. So let's take a look at question 2. We have 3 different students here, Laura, Nia, and Leo, and they solved the following 3 equations as shown. We can see all of their work and all of their answers. What I want you to do is identify each of these equations as having one solution, no solution, or infinitely many solutions. So you're going to pause the video, take a look at their answers, and I want you to guess. Okay, there are 3 students and 3 types of answers, so use the process of elimination. You're going to use each of them once. Go ahead and do that. So if I look at Laura, I'm not really quite sure how to answer Laura, so I'm going to move on and come back to Laura. Let's look at Nia. Nia got 2 equals 2. Is that always true? $2 equals $2. 2 pencils equals 2 pencils. Yes, this is always going to be true. So no matter what number we plug in, our answer is going to be a true statement. So we have INS, infinitely many solutions. And I'm going to cross out that answer. So again, if you look here, everything is the exact same. 3x plus 2 equals 3x plus 2. Leo. Leo got 6 equals 17. Is that a true statement? No. 6 is never going to equal 17, so there is no solution here. So I have only one possibility left. So if I take a look at Laura, Laura got x equals 1 number, 1 answer. So this is one solution. On the top of the next page, we are going to work through the Check Your Understanding box together. Please use the My Notes section of your book on page 26 to write out each step. Organize your work off to the side in that graph paper portion of your book called the My Notes. I'm going to draw my line down. I'm going to start with the left side. We need to distribute here. 3 times 2z is 6z. 3 times 4 is 12. I can't combine any like terms, so I'm going to move on. 6 times 5z is 30z. 6 times 2 is 12. I can't tell if this is no solution or infinitely many solutions yet, so I'm going to keep solving. I want my z terms together, so I'm going to decide to subtract 30z. Subtract 30z. We want to isolate this negative 24z, get it all by itself. So I want to move my constants together on the other side. So subtract 12, subtract 12. Oh, that cancels out. Negative 24z equals 0. Divide by negative 24. Whoops. Divide by negative 24. Z equals 0. 0 is one number, so this has one solution, which means that I can only plug in 0 for z right here and right here, and it gives me one true statement. If I was to plug in z equals 1, 6 times 1 is 6 plus 12. 30 times 1 is 30 plus 12. Those are not going to be equal. Same thing if we plug in 2 or 5 or 10, it's going to give us a false statement, which means the only solution, the only answer is 0, which is one solution. Question 4. Let's do the same thing here. Keep our two sides separate. I have a 3 out in front of parentheses. So let's distribute. 3 times x is 3x. 3 times 1 is 3. Bring down your plus 1 and plus 2x. I have like terms here. 3x, and 2x. 3 plus 2 gives us 5. But I also have another set of like terms. I have constants here. I have 3 and 1. So if I add 3 plus 1, we get 4. So combine your variable terms, your x's, and combine your constant terms, which are your numbers. On the right-hand side, 2 times 2x, I get 4x. 2 times 2 is 4. Bring down this plus x. We have a set of like terms here. I have a 4x and an x. If it helps you, go ahead and put a 1 out in front of that x. So it's 4x plus 1x gives us 5x plus 4. I'm going to stop right here because I can already see what my answer is going to be. What do you notice? Everything is exactly the same. My x terms, 5x is the same as 5x. My constant terms are the same. 4 is the same as 4. So no matter which number we plug in here, 100, -3, we are always going to get a true statement. So this question has infinitely many solutions. IMS. 4 equals 4. That's always going to be a true statement. So if everything is exactly the same, it's IMS. Question 5. I have like terms here on the left. 8b minus 10b. Why don't you go ahead and pause the video and try to work through this question. Do the left-hand side of your equal sign, do the right-hand side of your equal sign, and then we'll go through it together when you're done. 8b minus 10b gives us -2b plus 3 equals -2 times b is -2b. -2 times -2. I have 2 negatives, which makes a positive 4. Bring down the plus 3. Here we have like terms, my constant terms. So we need to do 4 plus 3. 4 plus 3 gives us 7. And I am going to stop right here. I can already see what my answer is going to be. What do we notice here? We notice that our variable terms are the same. -2b is the same as -2b. But what's different here is our constant terms. 3 does not equal 7. So this is going to be no solution. And I can take it a step further if I want to. Add 2b to both sides and those cancel. What we're left with is 3 equals 7, which is always going to be a false statement. So no matter which number we're plugging in, it's going to be false. So there is no solution for this question 5. So here, once again, your variable terms are the same, -2 and -2b. But what's different is your 3 and your 7. Okay. So go ahead and try question 6 on your own. You have 2 equations. Which of the following has no solutions and which has all real numbers, which is another way to say infinitely many solutions. So pause the video, Figure out the answer to A and B. Make sure you're explaining your reasoning. Letter A. 3x plus 5 equals 3x plus 0, because there's nothing there. So take a look here. My variable terms are the same, 3x and 3x. But what's different is your constants. Is 5 ever going to equal 0? No. If I'm plugging in 3 times 1 plus 5, that's not going to equal 3 times 1 plus nothing, plus 0. Or 3 times 2 plus 5 is not going to equal 3 times 2 plus nothing, plus 0. So this one has no solutions because on one side we're adding 5, on the other side we aren't adding anything, or we're adding 0. That's never going to be equal. Question B. Everything's the same. 4r and 4r, minus 2, minus 2. So no matter what number I plug in, I'm multiplying that r, that number, by 4 and subtracting 2 on both sides. They're identical. So this is going to have infinitely many solutions. No matter what number we plug in for r, we are always going to get a true statement. Question 8. Using your own words here, explain why this equation, x plus 3 equals x plus 2, has no solution. See what you can come up with. Write something down. This has no solution because some of you said my x terms are the same. We have x and x, but your constant terms are different. Great observation. Or some of you said that 3 does not equal 2. Therefore, this is no solution. This is a false statement. Question 9. What number could we plug in for A right here to make this equation have infinitely many solutions? Great job. A would need to equal 3. If the left side says 3x plus 5, then the right side would also need to say 3x plus 5 in order to make this infinitely many solutions. Your variable terms have to be the same. Your constant terms have to be the same. Excellent work.